Hello friends, welcome to engineering tutorial. So today we are going to resume our discussion on mechanics, which is kinematics. So far in the previous videos we have covered the basic concepts related to motion in a straight line, and we discussed some concepts related to it. We solved a lot of questions related to it. Then we discussed about relative velocity in one dimension, basic concepts, and then numerical problems we have solved. So in the next series of videos we will be discussing about another very important concept related to motion with constant acceleration. Okay, so we will be discussing about equations of motion, okay, which is very important. So first we will be deriving these equations, then we will be using these equations to solve various problems. Okay, so today's topic is equations of motion for objects moving with constant acceleration. Okay, this is very important, with constant acceleration, otherwise these equations are invalid. So basically everything that we discuss related to motion, it concerns about first the initial velocity, okay, the initial velocity which is represented as u, then the final velocity which is represented as v, then the acceleration which is represented as a, they are all lowercase, okay, small, then the distance or the displacement, actually the displacement s, and the duration during which everything happens, that is the time t. So these things are involved. Okay, so we'll be deriving a simple equation which is for a particle. Okay, let's say we have an object or a particle. It has certain initial velocity, let's call it u. It is moving along a straight line, and this is where the observation started. So this is initial time t equals to 0, okay, 0 seconds. It is moving along a straight line, and at a certain time instant, let's say t equals to t seconds, okay, t seconds, okay, it has attained a velocity v, which is the final velocity at that instant. Okay, and it is moving with a constant acceleration a. Okay, so we will be deriving the equations. Now if you remember, we have discussed about various concepts related to uniform motion in a straight line, average velocity, instantaneous velocity, then instantaneous acceleration, average acceleration, a lot of things we have discussed. So here the instantaneous acceleration is given by derivative of velocity with respect to time, okay, dv by dt. Here don't confuse it with the final velocity v. Here it is dv by dt, simply velocity, small change in velocity, small change in time. That implies this is equal to a, acceleration. That implies dv is equal to a dt, okay, it is correct, dv is equal to a dt. Now we have to integrate both sides, okay, dV and A dt. So here the question is, what are the limits of the this integration? So here everything concerned with velocity here on the left hand side, it will fall on the lower side, the initial velocity, which is u, the starting velocity, which will be at the lower end, the initial velocity, because at time t equals to 0, the initial velocity was u. Then the upper limit is the final velocity, which was recorded at time instant t equals to t seconds. So the two limits, lower and upper limit of the velocity dv, is u and v. Here acceleration is constant, so basically this will come outside the integration thing, this one A. Okay, this will come outside. Outside the limits of integration, outside the integration, because it is constant. And here for time, the initial time is t equals to 0, that is simply we will put 0, and the final time is t equals to t, this. Okay, so here it becomes, when we perform integration, it is v definite integration, v upper limit, lower limit, here it is a t upper limit t, lower limit 0. So here when we put the upper and lower limit values, it becomes v minus u is equal to a into t minus 0. I am assuming that you are familiar with the concepts of definite integration. So it is v minus u is equal to a t, or we can write it as v final velocity v is equal to initial velocity u plus a t. Okay, this. So this is the first equation of motion that we have derived. This is the first equation of motion. Okay, v final velocity v is equal to initial velocity plus acceleration and time, the product of acceleration and time, this. Okay. Okay, so we have got the first equation of motion, which is final velocity v is equal to initial velocity u plus product or multiplication of the uniform or the constant acceleration and the time duration. Okay, this is the first equation of motion. Now we will be using this, we will be manipulating this equation to get the second equation of motion, which will be relating displacement and the initial velocity and acceleration, constant acceleration and time. This is final velocity, initial velocity, acceleration, time. Okay, these parameters are interrelated. Okay, suppose we want to write this final velocity as everything, as I said, everything related to this for the object, okay, which started at time t equals to 0 with initial velocity u. It traveled in a straight line with constant acceleration a, and at this point attaining a final velocity v after a time duration of t seconds. Now let's say in this t seconds the displacement which occurred is s meters or whatever units you want to take, okay, s. So here we can write this v is equal to u plus at as ds by dt. The final velocity we are replacing it with ds by dt is equal to u plus at. Okay, because we know velocity is equal to displacement by time taken. We have already discussed it in the basic concepts related to motion in a straight line. Okay, velocity is equal to displacement by time taken. So here in this duration of t seconds, starting with initial velocity u with a final velocity v, the total displacement is s. So we can write the final velocity v as ds by dt, which is equal to u plus at. Simply we have substituted final velocity v with ds by dt, nothing else. So then we can write it as ds is equal to u dt plus at dt. Alright, okay, simply we have taken this dt here. Okay, now we have to perform integration on both sides. Okay, so integration of ds, integration of u dt, integration of at dt. Again, this is definite integration, so we have to choose the limits. Here for displacement, the initial displacement is 0. At time t equals to 0, it is 0. Okay, and at the end of the duration, time duration, that is t equal to 2 seconds, the displacement is s. This is here 0 meters, let's say it is s meters or whatever units. Okay, so here the lower limit of integration is 0 and the upper limit is s. Here the variable parameter is time dt. Again, the observation started at t equals to 0, so here the lower limit will be 0 and the upper limit will be t. Same case here, dt, the variable parameter is time, so lower limit is 0, upper lit is t. So when we perform integration on this definite integration, it becomes s 0 equals to u t 0 plus, here acceleration is constant, so it will go outside, it will simply be t dt. Integration of t dt is t square by 2, this t 0. Acceleration is constant, so it goes outside. Okay, so here it is like this, acceleration is constant, this one, a integration of t dt 0 to t, which is equal to a t square by 2, which is t 0, like this one here. Okay, so this becomes, that implies s minus 0 is equal to u into t minus 0 plus a by 2 into t square minus 0 square. So this becomes s is equal to ut plus half at square, which is the second equation of motion. Okay, this is the second equation of motion, this one. So this interrelates the displacement, the initial velocity u, the time duration t, and the acceleration a. Okay, these parameters are involved in this equation, the second equation. The first equation was between the final velocity v, the initial velocity u, acceleration a, and time duration t. Now let us make some manipulations here to, actually it is not it is not considered an equation of motion, but it is a very good formula to use while solving problems. Okay, so we'll be doing this. So let's say we have this equation which we have derived, ut plus half at square. Suppose we write it in this way, okay, u plus half at taking t common like this, okay. So this becomes 2u plus at by 2 into t, or we can write it as u plus at into t by 2. So here if you focus on this u plus at, this is the first equation of motion, which is the final velocity v. Okay, so this is basically, we can write it as u plus v, this one, u plus at, here we are replacing it with v, the first equation of motion, into t by 2. So this is S. This is also a very good formula which interrelates displacement S, initial velocity u, final velocity v, and the time duration. Okay, this another important equation of motion. Okay.